So I'm just gonna show another method for making threads on for a screw that doesn't involve adding material to the main cylinder, but rather subtracting material from the main cylinder. It's basically like an helix that's cutting material from the main shape. The only thing that um, it's a bit more technical is that we're extending the bottom and top parts of the helix outwards, so that we'll have these cut here. Because otherwise, if this wasn't here, then the cut would just stop here and you'll have like a big inner face. So we can make something from scratch. Let's say that we have a cylinder that's, let's say, 10 centimeters radius and then height 50, for example. And then we can use the regular helix from Max. It's not really necessary to have like a plugin like I showed last time. Something cool that I sometimes use now is that since Max, I think it was in 2024, they added the ability to copy controllers from one object to the other, values from controllers. So I will align the helix to this shape, and if I right click on the radius for the cylinder, I can copy the controller, in this case the radius, and I can paste that in other sections. So I can paste controller instance and then do the same here, paste controller instance, and either you change the radius of the cylinder or the radius of the helix, all of them are going to change. So now we're using the helix. We're going to use the sweep modifier again to have to make the inner cuts. So I'm gonna use a custom profile, and I'll actually just draw the profile. I'll make like a rectangle, and I will convert to spline, set all the points to corner, and just make this a rough thread shape, something like this. Then I can just like use the pick and select this one. So as you can see, this is pointing to the right, but then here is pointing to the left. So it's carving from the going on the opposite direction, which is actually what we want. But in case you wanted this to be flipped to the other side, like we did like in the previous video, you can just like mirror on the XZ plane. But this isn't actually what we want. We just want this to be the way it is. Then, for example, if you notice that you want a bit more of a deep cut, you can just change the X offset and just like bring this inward like so. And then if this isn't enough, you can change the profile of the thread directly here. You can move this and it's going in, and then something like this. You even make it something like this. Okay, so now I'm just gonna change the sides of the main cylinder to 32, and then we can apply a boolean. Cool, so this is what we have roughly. And like I said, the thing that's missing, it's these faces. They need to like be extruded along their normal outwards. So the way to do this is we have to use the volume select, and then we're going to have to apply a multi-sub-object material to this thread, to this helix. So I have one here. It's a RGB color-coded material with 3 IDs. I'm going to apply this here. And then if you notice, I have the top and bottom automatically with different colors. And this is because I have the generate material IDs turned on. Because otherwise it's just going to be one material ID for the whole mesh. And because of this, we can take advantage of the volume select material ID surface feature, where when this is turned to material ID 1 and this is set to face, you can select a specific face with that material ID. Then we just use the face extrude. We set this to, let's say, 20. We put another volume select, set to face. Material ID we set to number 2. Another face extrude, set this to 20. Then if we want this to be a bit more, how do we say, smooth, we can put a turbo smooth set to smoothing groups. What you'll notice is that the smoothing groups on these new faces are not the way that they should. So the way to fix this is to add another volume select where you change, you don't actually need to change anything because you just want the whole object, just need the whole object, and then you put a smooth modifier set to auto smooth. So now all the faces are being selected with this volume select, and then they're being smoothed automatically, and then the turbo smooth now is smoothing by smoothing groups like perfectly. So if we turn on the cylinder and turn off the helix, now we have those faces being extended properly. What we can do now is we can also put the turbo smooth by smoothing groups on the main shape, because this way it's more smooth when we decide to apply our remesh. Let's put 0.3, add like a Gaussian, and we have something like this. We can obviously change the voxel size, lower it, and start to have like more crisp edges where we want to, but for the purpose of the video this isn't really necessary. I will say though that there's multiple things that we can do here. For example, we can tweak the profile that we're using, make this nice and round here, and then fuse and weld, possibly change the steps to, let's say, 2. So this is more, I could even do 1. Now let's say 2. And like I said, since the cut, the helix cut and this face extrude is being done procedurally, that means that we can change the number of turns automatically. So something like this. It's always going to be with the ends of the faces that are at the end of the helix always being extruded outwards, regardless if we change the number of turns or not. And because we copy the controller for the radius from the main cylinder, that also means that we can just change the radius, and the thread is being, it's basically following. And since the profile is being used to change the way that this is being cut, let's say that this is the number of turns that we wanted. We don't want to actually change the number of turns. Then the next best thing that we can do to change this thing is to just change the profile. So potentially just increase something like this. And then if you notice that this is not actually aligned, which it isn't, because when you have like these Bezier tangents and you change something, then you need to reset the points. You know what, let me just change this to corner. Actually this works nicely when we're doing it this way, because since we have the turbo smooth on the helix. Oh, let me just check something. There we go. Okay. So now we have something like this, and it's always procedural. It might seem like it's a bit overkill to make something like this, but for example, I had to do something similar some time ago where I made like uh, these specific iron sights, and the number of threads that I added for the blockout were not enough, so I had to change that in the iPoly stage. And because I did something similar to this setup that I showed, it was actually easy to change that. So it ended up looking like this roughly. Yeah. So I think in general the takeaway is that using the multi-sub object with different IDs allows you to use volume select in the surface features to extrude areas that you want. And you know that this is procedural because we can do something like this. We can put like a volume select around here, choose face, and then use the sphere. Like this. And if I put a material ID 1, which is the one on the bottom, that means that those faces are being extruded. And then if I move the gizmo around, those faces are changing accordingly. It can be useful in some cases. But yeah, this is how I made the X screw.